All right, so today we're going to apply some of these things we've learned about exponential and logarithmic equations. And so we're going to learn a few formulas that we're going to use. And so the first two are for doubling and for tripling. All right, and then on what you're going to notice on all of these formulas, the very first thing after the equal sign is going to be the initial amount. All right. And then if it's doubling, then the base is going to be 2. If it's tripling, the base is going to be 3. And then after we're done with a couple of those, we'll talk about another formula or a couple other formulas. All right. So on example 1, a bacteria culture contains 200 bacteria, and the number of bacteria doubles every hour. So this 200, that 200 is going to be the initial amount of bacteria, and so it's going to be P. So you can do that if you want to, label that as P. And so on example A, it asks us to write a function and to call it y. Now that's not a super big deal, but since it's telling us to call this function y, I am going to go ahead and do that. So instead of a equals, I'm going to write y equals. So we want to write a function called y to represent the number of bacteria in the culture after X hours. And so on all of these formulas, the very first thing that you put after the equal sign is the initial amount. So in this case, it's the initial amount of bacteria.
Everyone put y equals 200?
No. The initial amount is going to change from problem to problem. So, but every time it's always initial amount first. All right. And then this one is going to double. So 2 is going to be our base. And then it tells us for X hours. So we're going to have our exponent be X. All right. And then for B, it's to ask how many bacteria will be in the culture after 6 hours. So what are we going to do with that 6? Are we going to put it in for y, or are we going to put it in for x? We're going to put it in for x. So y is going to be equal to 200 times 2 to the 6. All right, so after that amount of time, there's going to be 12,800 bacteria. So that's how you use the doubling formula. All right. So on example 2, it says that each day an investor deposits 3 times as much into the bank as she did the day before. Her initial investment is $2. And so P is going to be that $2. It's the initial amount. All right. And then for A, we're going to write a function to represent her daily deposit. And again, we're going to call it Y. So instead of A equals, we're going to do Y equals. And then it's going to be the initial amount, which is 2. And then for this situation, which formula are we going to use? Doubling or tripling? Tripling. So it's going to be 3 to the x. All right. And then for the B part, we want to know what her deposit is on day 8. Okay, that's a pretty big deposit. $13,122. So it almost seems like this is something you could do. Just start with $2 and the next day deposit $6. But eventually, like just after 8 days, it's already up to $13,122 that you're depositing. Yes.
How did you get the 8? Because B has 8.
Day 8. Yep. I couldn't do this for very many days, and I would definitely not have enough money. Okay. And then the other formulas we're going to use are for appreciation and for depreciation. So over time, pretty much anything that you purchase either gains value or lose value. If those items gain value, it is appreciation. And when those values lose value, it's depreciation. So can you guys think of things that gain value over time? Yes. Yes. So like baseball cards are something that you would collect. That's something that is good to invest in. Another thing that if you get one day when you guys have money, a good thing to invest in is land. Land pretty much always gains value. You don't have to do anything to it and it will gain value. Right? Things that lose value are things like vehicles. They always lose value over time, usually pretty rapidly. Something weird's going on right now with cars, but most of the time they lose value pretty quickly. Tractors, trucks, all those things lose value over time. So if something appreciates or gains value, this is the formula we're going to use. So A is after a certain amount of years. P is the initial amount, just like the other ones. The first thing after the equal sign is initial amount. R is the rate of growth or decay as a decimal. So we need to talk about that. And then on both of these formulas, your time is going to be in years. All right, so on example 3, a plot of land is valued at $30,000. The value of the land is expected to increase at a rate of 9.2% annually. Now, we need to change that percent to a decimal. In fourth period, nobody really remembered how to do that. So whenever you change a percent to a decimal, you're going to take the decimal point and you're going to move it 2 places to the left. And if there's like an empty space, you're going to fill in a 0. So 9.2% is 0.092 as a decimal. So these formulas don't work with percentages. They only work with decimals. Okay, so that's going to be R, 0.092. What about this $30,000? What do you guys think that's going to be? Like what letter up there? It's going to be P. The initial amount is $30,000. Okay. Now we're going to write a function to model this value. It didn't tell us to call it a certain thing, so I'm just going to go ahead and use A like the original. So A equals whatever the initial amount is. All right. And then because this increases, we're going to do the equation with the plus. 0.092 raised to the t. Right. Now, sometimes on your problem, they just want you to write it and be done. These examples, I'm having you do a little more just for practice, but if it just asks you to write a function to model, you're done. But then if it asks you to use it, like this one, we're going to put that 3 in for t and figure out what happened with this land just sitting there for 3 years. Okay, so it gained over $9,000 in 3 years just sitting there. So definitely a good investment. All right. We are going to only do one more, so that those last two examples we're going to kind of not worry about today. All right, so on example 4, we have a new car that is valued at $25,200 in 2011. The car depreciates at a rate of 12% each year. Now we're going to find the value of the car this year. So let's find the value of the car in 2023. All right, so I know that 25,200 is going to be P. And I want to take that 12% and I want to change it to a decimal. Do you guys know where the decimal is if you don't see it? Yeah, it's at the very end. So I'll take that and move it 2 places. So we're going to use 0.12 for R. And then what should T be? Like how many years has it been since we started? The car was purchased in 2011. And we want to find, we changed it. We changed it to 2023. Sorry. So what should I almost said it. What should T be? 12, yeah. All right, so 20, we'll start off and just write the original formula. Now, since this one is losing value, we use the formula with a minus.
So are they always going to be increasing or decreasing?
Today, yeah, I guess so. Now, we are going to learn some more formulas tomorrow. The ones tomorrow are all about money growing. So it's decreased a lot. I mean, that is a long time to have a car. But after 12 years, we're down to, I had a different. $5,434.91. Okay, so we're gonna skip example 5 and 6. I'm gonna give you your assignment, and then I'm gonna tell you which ones you can skip on your assignment also. All right, so the ones I don't want you to do are 6. It's about Alex. Sorry, Alex. There's 6. And then you can mark out 7 and 8.